Very good morning to everyone. So in the previous class we have completed unit number 6, state feedback controls. And as per our syllabus concept, we have to complete unit number 5. Unit number 5. The title of unit 5 is Design of Discrete Time Control Systems by Conventional Methods. Design of Discrete Time Control Systems by Conventional Methods. Okay. So this particular unit is also very simple as it is having only three particular topics. Three topics are going to be there in this one, and in this one, in this one, 50% of portion is going to be covered with control system syllabus. 50% of the portion is going to be completed with control system syllabus. Why? Because while discussing about the syllabus, so the first topic is transient and steady state specifications. Transient and steady state specifications. Design of that means the frequency responses in W plane for lead and lag compensators, lead and lag compensators, and root locus technique in jet. Root locus technique in jet. Only three particular topics are there in Unit 5, and it can be completed within 5 to 8 years. 5 to 8 classes. Why? Because the transient and steady state specifications are very similar to the topic which you have already learned in control systems. Transient and steady state specifications. Transient state specifications are nothing but related to the time response characteristics of second order systems. Transient specification are that is transient state specifications are nothing but the time response characteristics of the second order system. That means these are the concepts regarding to the rise time, peak time, delay time, check-in time. All these responses or specifications are very similar. Same topics has been included in this unit also. Same topic. And while going about the steady state specifications, these are the specifications regarding to the type 0, type 1 and type 2 systems. Type 0, type 1, type 2 are nothing but proportional, constant or error, velocity error and acceleration error. Proportional, velocity and acceleration errors. And these specifications are regarding to steady state specification. Same concepts are going to be repeated in this unit also. Those are transient and steady state specifications. So this first topic, that is transient and steady state specifications, are very well known to you. Why? Because all these concepts are studied by you in your control systems scenario. Control systems scenario. Nowadays, control system scenario is similar to the topics in control systems. And while coming for the second topic, that is frequency response analysis of lead and lag compensators. Frequency response analysis of lead and lag compensators. Okay. So this particular topic is very new. It is a novel topic, and it is going to be discussed. And the third topic is root locus technique in jet plane. Apart from the jet plane, the topic is root locus technique. Root locus technique means this particular root locus technique is also very very low to you. Why? Because so many, not so many, plenty problems or plenty number of problems are solved with our control system. Same procedure. Okay. So apart from all these more things, I am discussing these topics briefly. I am going to discuss all these topics briefly. So, as far as your syllabus concerned, as far as your syllabus concerned, unit number 4, unit number 5, and unit number 6, and also unit number 1 are small units. Small, and unit number 2 and unit number 3 are simple. Are simple. Okay. So, regarding to the digital control systems, it is simply scoring something. Simply scoring something. Okay. So why? Because all the topics are very familiar to you. If you practice 1 to 2 times, all the problems will be very well known to you. Just understanding the concept and try to solve how to solve the problems. It is very easy. It is very easy. Why? Because while talking about the second unit, it is simply jet transfer. Jet transfer. All the topics, all the problems we have discussed, all these problems are very well known to you. Okay? Apart from the problems of the general songs, a small topic has been included in the one, that is pulse transfer. Pulse transfer. Okay. So without any delay, let us enter into the fifth unit. Fifth unit. Let me share the PDF file to you. This is the PDF file. Hope you are familiar about this one. Yeah. That's one. The first topic we are going to discuss, that is the transient response and steady state response specifications. Okay. So while talking about the specifications, let me discuss what is a transient response and a steady state response. This transient response mainly discussing about the system closed loop codes. These are going to be discussed with the closed loop codes of the system. Transient systems or transient response is nothing but which is corresponding to the closed loop codes of the system. Closed loop codes of the system. And similarly, the steady state responses are related to the poles of the input function. Are related to the poles of the input function. Why this transient response and steady state responses are used? So while discussing about any particular system, the main concern is stability. That is, the main requirement of any control system is stability. Stability. Okay. So in order to analyze the stability of this particular system, the transient response steady state responses plays a vital role. Okay. So once again, the basic requirement of any control system is stability. Stability. Whether it may be relative stability, absolute stability, whatever may be the case, or whatever may be the system, whether it may be a continuous system or a discrete system, whether it may be a time dependent or frequency dependent. The basic requirement of any control system is stability. And this stability is going to be judged with the help of a transient response and steady state response. Okay. So this transient response is related to the closed loop force of the system. Similarly, the steady state response is related to the poles of the input function, whether it may be a unit step, ramp, parabolic, etc. So these are about the transient responses and steady state responses. Now let us enter or step into the transient response specifications. Transient response specifications. So in order to analyze the performance characteristics of this particular systems, that means in terms of the time domain quantities, unit step input function is commonly used. Unit step input function is commonly used. Why? Because it is very easy to generate this step function, and it can be represented easily, and the main thing is with this unit step function, there will be no drastic change in the control system. Drastic change in the control system. But but we can analyze the transient and steady state responses. Okay? Once again, in any control systems, while talking about the things, practical things, the performance characteristics are going to be analyzed in time domain quantities. The performance characteristics are analyzed in time domain quantities. So basically, for this one, basically, a unit step input is going to be taken. Is going to be taken. Why? Because while you are using a unit step means this unit step function is very easy to generate. That is, unit step function can be easily generated and it can be easily represented. So, with this input, that means unit step as an input, there will be no drastic change, but it will provide the complete information regarding to both transient and steady state responses. Transient and steady state responses. So initially, we will discuss about the transient responses. Transient responses. So, the transient response of a system basically depends upon the initial conditions. So, in order to determine the performance characteristics regarding to the transient responses, that responses is basically depend upon the initial conditions of the system. Initial conditions of the system. So while talking about the practical control systems, we will consider that system is initially at rest condition. We will consider that particular system is initially at rest position. Rest position. Okay? Why? Because the transient response, that means in order to determine the desired performance characteristics related to the transient response, we have to consider the initial conditions. The initial conditions. So while talking about the practical control systems, we have to consider this particular system is initially at rest. Initially at rest position. So let us consider a simple block diagram regarding to the control system. That means a closed loop digital system. Closed loop digital system. So this is the block diagram which is going to be representing the closed loop digital system, which is consisting of a digital controller in cascaded position of zero order pole, which is in cascaded position of the plant. The plant is the system which is going to be taken, choosing. Okay. So let us consider this particular system as a closed loop digital system. Why? Because it is consisting of a feedback, unit feedback. So it is considered as a closed loop system. Closed loop system. Whether it may be the feedback is unity or not. But it is a simple closed loop digital system. Okay. So in this one, just to have the digital controller during the process, it has to be cascaded with a sampler, which we have discussed in the unit 1. Why the sampler is going to be used, why the ideal sampling is going to be carried over. All these topics we have discussed in the unit 1. Okay? So, the digital controller is to be in the process, it has to be cascaded with a sample. Cascaded with the sample. So let us suppose R of t is the input which is given for this closed loop system. Closed loop system R of t, and C of t is the output which is obtained from the. So the input which is given for the sampler is considered as error signal. That is your error and your. So as soon as the sampler is in the closed position, this error signal will be given as an input to this digital controller, and simply it will convert or process this particular signal into discrete steps, steps, and it will be given as an input to the whole circuit. Okay, zero on a whole circuit. So as per the requirement of the user, it will holds, it will holds that particular digital signal for a while. That means if the user is asked us to hold that particular circuit for a instant, for a particular instant, this zero or a whole circuit or a whole circuit will holds that particular signal for a prescribed time which is given by the user, and after that it will be processed for the clock. So therefore, this input R of t is going to be converted initially as an error signal, and it is given as an input to the digital controller to a sampler, and it is going to be processed through whole circuit and plant, and it is going to be taken as an output from this closed loop system as CO. As but the C of t is nothing but an output which is comes from this particular system. But we need that particular output in terms of the digital. We have to derive this output signal in terms of digital system, in terms of digital scenario. Therefore, the sampler is going to be adopted after the output so that this C of t is going to be converted into the digital, that is C of kt, through this particular sampler, and this particular capital T is a sampling period. This particular capital T is a sampling period. Therefore, C of t is going to be converted into the C of kt, through a sampler which is having the sampling period called capital T. Okay. So this is the analysis regarding to the block diagram representation of a digital system. What type of digital system? It is a closed loop digital system. Closed loop digital system. How the R of t is going to be converted into the C of t, and again the C of t is going to be converted into the C of k. C of k. Okay. So while talking about the transient response of the digital control system, that means similar to the continuous time case. Continuous time case, it can be characterized with following specification. Following specification. That means with similar to the continuous time case, the transient response of the digital control system can be characterized can be characterized as follows. The first specification is regarding to the rise time. The first specification of the transient response is regarding to the rise time, and it is represented as TR. TR is a fixed where T is nothing but the time and smaller is nothing but the rise time. So, so what is meant by the rise time? So from now onwards, all the topics are very familiar to you. All these topics are discussed or studied by you in our control systems. So don't get confused. All these topics are very familiar to you regarding the unit 5. Okay, I am once again briefly explaining all the concepts. Okay, the first specification regarding to the transient response is rise time. Okay, and coming to the definition part of the rise time, the time required by the unit step response to rise from 0% to the 100% of its final value, while in case of the underdamped system, or the time required for the unit step response to rise from 90%, sorry, 10% to the 90% of its final value in case of overdamped system. Overdamped system. That means rise time is going to be characterized or deviated in two scenarios. That means in case respect to the underdamped system, or in case respect to the overdamped system. Okay. So while talking about the underdamped system, rise time is going to be defined as the time required for a unit step response to rise from 0% to the 100% of its final value. The time required for a unit step response to rise from 0% to the 100% of its final value is called as the rise time regarding to the underdamped system. And similarly, the time required for a unit step response to rise from 10% to the 90% of its final value is called as the rise time regarding to the overdamped system. Regarding to the overdamped system. Okay. So this is the first specification, that is nothing but price time. The next one is according to the delay time. Delay time. And it is going to be represented as T, T, where T is nothing but the time and D is nothing but the delay. Okay. While talking about the definition of this delay time, the time required for the unit step response, while I am repeatedly using this unit step response, because as we have discussed in the earlier, in case of the practical control system, we are using this unit step response as an input. Unit step response as an input. Because, because it can be generated easily and it can be represented and it can be represented easily, and there will be no drastic change for the total system. They will taking off or considering the unit structures. Okay. So while discussing about the definition of this particular transient response specifications, I may repeatedly use the word unit step response. Okay. So while talking about the delay time definition, the time required for the unit step response to reach 50% of its final value. The time required for a unit step response to reach 50% of its final value is called as delay. Is called as delay. Okay. This is the second specification, that is second transient state specification of a closed loop digital system. Closed loop digital system. And the next specification is regarding to the peak time. Peak time. And it is going to be represented as T suffix. T suffix, where T is nothing but the time and T is nothing but the peak, which combined with called as peak time. So peak time is going to be defined as the time at which the maximum peak is going to be occurred. The time which is going to be occurs maximum. So while considering about the maximum time of the unit response, that particular maximum peak is considered as a peak. Therefore, it is going to be defined as a time at which the maximum peak is going to be. This is a third transient state specification. The fourth specification is regarding to the peak overshoot. Peak overshoot. And it is going to be represented as m suffix p. M suffix p. So this peak overshoot is going to be taken as a difference. Is going to be taken as a difference or change between two quantities. Change between two quantities. The first quantity is maximum speed, maximum peak, and the second quantity is steady state value of peak overshoot is according to the difference or change of two quantities according to the unit step response. The first one is maximum peak value of unit response, and the second quantity is steady state value of the unit step response. Therefore, the peak overshoot is going to be defined as the difference between maximum speed and steady state value of unit step response. Once again, the peak overshoot is going to be defined as the difference between maximum peak and the steady state value of the unit response. The difference between the maximum peak and the steady state value of the unit step response is called as the peak overshoot. And while talking about the settling time, that is the fifth transient response specification is settling time. Settling time is very, very important. That means settle. The system is going to be comes to the rest position. Settling. It is going to be represented with T suffix S, where T is nothing but time and S is nothing but deadline. Settling, it's commonly called as the settling time. So, settling time means the system is going to be comes to the rest position. Okay, so it is going to be defined as the time required for the unit step response. The time required for the unit step response to reach and stay in the relaxed position within 2 to 5% of its steady state value. 2 to 5% of its steady state value. Once again, I am discussing about the definition of the settling time. The time required for the unit step response to reach and stay within 2 to 5% of its steady state value is called as the settling time. Is called as the settling time. So all these specifications are regarding to the time response characteristics of a discrete time system. So let us consider this is a unit step response of a discrete time system. Unit step response for a discrete time system. Unit step response for a discrete time system. Okay. So let us consider this is a output response of a discrete time system. From all these specifications are regarding to this particular unit step response of a discrete time system. So let us consider here the maximum value. The maximum value is going to be represented as C max. C max. While talking about the discrete output system, this maximum value is going to be represented as C max star or C max conjugate. C max conjugate. So this C max conjugate is always less than or equal to C max. That means this C max value will be always less than or equal to, sorry, C max conjugate will be always less than to the C max value. C max value. So while talking about the sampling period, that means capital T here. Here. This particular capital T is called as the sampling period. So while talking about the sampling period, is small, then then the C max conjugate will also be very less, and hence the error is negligible. The error is negligible. That means while talking about the sampling period capital T, if the sampling period is quite small, quite small, the Cmax value will be less. The Cmax value will be less. The Cmax conjugate will be less, so that the error, the error between this particular Cmax and Cmax conjugate will be negligible. Negligible. That means if the Cmax value and Cmax conjugate value with respect to the sampling period, these two quantities are going to be related to the sampling period. So as soon as the sampling period is very less, the Cmax conjugate value will be also very less. Therefore, the difference between this Cmax and Cmax conjugate value, while talking about the oscillations, that means whenever the disturbance is going to be happening, The difference between the Cmax and Cmax conjugate will be negligible. Even the oscillations is going to be, it means whenever the disturbance is going to be different. If the sampling period capital T is going to be considered as a small, is going to be considered as a small value. Okay, so this is about the transient state responses and their specifications. Transient state responses and specifications. Okay, so this is the first topic we have discussed. While talking about the first topic regarding to the unit 5, the first topic is regarding to the transient and steady state responses. Yeah. The first topic regarding to the unit 5, that is design of the discrete time control systems by conventional methods. The first topic is transient state specifications. That means we have discussed what is going to be a transient time and what are the specifications regarding to the transient time response. Okay. So in the next class, we will discuss the topics regarding to the steady state specifications, and after that we will enter into the third topic of this unit. Third topic of this unit is the root locus technique with respect to the jet. The root locus technique with respect to the jet stream. Root locus technique with respect to the jet. So after that we will discuss about the lead and lag conversions. Lead and lag conversions. Okay. So with this I am going to wind up the class for today. Thank you everyone. Have a nice day.